प्रथमेश व्हिडिओ बंद करून ठेव तुझा. प्रथमेश मोरपे. Write your name and seat number in the chat box. If you want to ask anything, you can unmute yourself and you can ask, because I have on the option of unmute. So if anyone want to ask some questions or anything regarding the question paper pattern or practicals, you can ask. I will give 2 minutes and then we will start the remaining part of this chapter. Yesterday we due to the internet connection, there was too much disturbance of the connectivity. So I will talk regarding the practicals first, and then we will start the remaining session, remaining part of the chapter Ionic Equilibria. So regarding the practicals, don't take tension of the practicals, because when the college will open, no one will tell when the college will open. Government is also not know when we have to start the junior colleges, but when the college will started, then we will take the decision of the practicals, how many practicals we have to conduct. Till now, in the HSC board evaluation criteria, we have given only 60% practicals we have to conduct, but now it is also not possible to conduct 60% practicals due to this pandemic situation. So my request to all the students, please purchase practical notebook. This practical notebook is also the handbook cum journal. Now no any separate handbook will be provided, or no any separate journal will be provided. In the same notebook, we have to write the practicals. At the time of board exam, this practical book we have to submit. This is having 5 marks weightage. Later on, we will discuss about this practical notebook and question paper pattern and everything. So don't take tension about the practicals, because yesterday 2-3 students message me regarding the practicals, when these practicals will be started and which practicals will be for the board exam. No one knows about the practicals, when the practicals will be started or when the examination will be there, practical examination. So as a member of HSC board chemistry, we are going to conduct this practical exam internally this year. We have already given this, what you can say, a letter to the HSC board due to the pandemic situation this year. No external should be there, so the practical should be conducted internally, but board not received this letter. But we are trying to conduct the practical exam internally. Later we will see about this practicals exam. So focus on the theory examination. Already the syllabus is reduced. So my request to all the students, only the reduced syllabus will be asked for the board examination, and whatever the part it is deleted, it will be not asked for the board examination only, remember. For the board examination, I am talking about the board examination. I am not talking about the competitive examinations. Whatever the competitive examinations are there, JEE, NEET, CET, the entire syllabus will be there, because there is no any notification from the CET cell, no any notification from the JEE, NTA, that is National Testing Agency, who conducts the JEE and NEET exam. So those students who want to appear for these competitive examinations, they have to learn, actually they have to read all the reduced syllabus also, and non-reduced syllabus also. So in this chapter, ionic equilibria, we already learn about the electrolytes, strong electrolytes, weak electrolytes, then Ostwald dilution law, then what is meant by acids, base, Arrhenius theory, Laurie-Bronsted theory, Lewis theory, then the concept of hydrolysis, types of salts. Salts, there are 4 types. We buffer action, then what is meant by buffer solution, what are the applications of buffer. So the questions will be asked on this part. Remember, this is the very important part in this ionic equilibrium chapter, and one numerical will be there. Either it will be for 2 marks or 3 marks. So this is the some important topics I discussed. Once again, I'm repeating: Arrhenius theory, Lewis theory, Laurie-Bronsted theory, then types of salts, concept of hydrolysis, then what is mean by strong electrolytes, weak electrolytes, then what is mean by solubility product, common ion effect we will discuss today, and we will complete this chapter. In the end of the slides, in the end of the presentation, I have given all the solved examples from the exercise. So go through this exercise. I have already, I think the PPT is sent to you, but in that PPT, these solved examples are not there. Today again, I will send the PPT, updated PPT, in which all the examples are solved. So we will get the answers of the questions. And the numericals will be asked from the exercise, only the values will be changed. No any numerical, it is asked from the solved problems. Means as it is solved, problems will be not asked, values will be changed. So note this notice. As it is, no any question will be asked. I am talking about the numericals. So the 100% the values will be changed, but the format will be remain same. So I think yesterday we are discussing about this solubility equilibria. In one line, I will explain this solubility equilibria. Actually, this is asked for the uh, definition purpose, define solubility equilibria, or define solubility product. So it is a solubility equilibria. It is nothing but the equilibrium between. So the definition is given here. See, the dynamic equilibrium which is exists between undissolved solid and any undissolved solid. Here we are taken the AgCl. That's why here AgCl is given. So remember, this solubility equilibrium, it is a equilibrium between undissolved solid and dissolved ions in saturated solution. It is called as solubility equilibrium. Once again, I am repeating the definition. See, solubility equilibrium, it is the dynamic equilibrium between undissolved solid and dissolved ions in saturated solution. It is called as solubility equilibrium. We also discuss about this expression. This is same as ionic product of water, K into K dash, K into K dash. This is called as ionic product of water. Here the concentrations we are taking in saturated solution, remember. And in case of ionic product, we are not going to take the we are taking the concentration at any stage. But here, in case of solubility product, we are taking the concentrations at in saturated solutions. Remember, this is the difference between ionic product and solubility product. So in general, if the general salt is given, suppose this is a salt BXAY, where X and Y, these are the coefficient of B, X is a coefficient of B and Y is a coefficient of A. This salt will be dissociates as X, this is a coefficient of B, B raised to Y, and X into A raised to X. So KSP is given by, KSP is nothing but, this is a solubility product. This solubility is given, see the concentrations, B raised to Y plus means we are taking the concentration of this B raised to Y plus, raised to X means again raised to the power, coefficients are there in the balance equation. So this will, you will understand this by taking the examples. I think examples also we discussed these examples. So with these examples, we have to prepare the definition of solubility product. So by this example, BaSO4, we will prepare the definition of solubility product. So solubility product, this is the solubility product is given. So we will prepare the definition of solubility product by this dissociation. Solubility is a product is the product of, this is the product of, see the definition is given here, side by side also we have to see the definition. The solubility product, it is the product of equilibrium concentration. See, means these are the concentrations at equilibrium and also these are the concentrations in saturated solution. This is the difference between ionic product and solubility product. See, solubility product, it is the concentration at equilibrium only and in saturated solution. Whether ionic product, these are the concentrations at any stage, means the concentration at any stage. But in case of this solubility product, we are considering the concentrations at equilibrium and in saturated solution. Remember, this is the difference in between ionic product and solubility product. So again, we will prepare the definition in solubility product. This is the product of concentrations of constituent ions, because these are the constituent ions. See, the definition is also given. This is the product of equilibrium concentrations of the constituent ions raised to the power. See, the raised to the power equal to their respective coefficients in the balance equilibrium. So in this we are taking 2 also. So see here, 2 is given because it is the coefficient of the ions. So we can prepare the definition by using this different examples. Solubility product, it is the product of concentrations of the ions at equilibrium raised to the power equal to the respective coefficients. We can prepare the definition in your own words, but the definition should be correct in saturated solution. So I have given the standard definition here. We can prepare your definition according to this dissociation constant KSP. This definition can be asked for 1 mark, and this is also useful for our numerical purpose. For solving the numericals, you must know what is meant by solubility product. Then we will discuss this relation between solubility and solubility product. The relation between solubility, see the solubility I will explain. Solubility means the amount, the compound, see I will explain the solubility first. Solubility of a compound is the amount in grams, remember. Solubility always expressed in grams, and molar solubility always expressed in moles per, it is a grams per liter and it is a moles per liter, remember. Solubility is grams per liter and molar solubility is moles per liter. This is the difference between solubility and molar solubility. So solubility is the amount, solubility of a compound is defined as the amount in grams that dissolves per unit volume. The volume may be 100 ml or 1 liter of its saturated solution. So this is given for your understanding purpose. This will be not asked for your exam, but this molar solubility can be asked for the examination. No any definition will be asked. It will be asked for the numerical. So for the numerical purpose, you must know what is meant by molar solubility. As the molar word is there, so the number of moles of that compound that dissolved to give 1 liter of saturated solution. It is called as molar solubility. So the definition, according to this definition, this formula is created. So molar solubility is equal to solubility in grams per liter divided by molar mass in grams per mole. So the solubility is equal to, we can multiply this into molar solubility. So if the solubility is asked in the numerical, we have to write solubility is equal to molar solubility into molar mass. The units we have to write in bracket. Molar solubility is denoted in moles per liter and solubility is denoted in grams per liter. Only note this change, moles per liter and grams per liter. So molar solubility, again one equilibrium is given. Molar solubility is denoted with this symbol S, remember. S is the molar solubility of the compound. Directly I am coming to some examples. So by using these examples, we can understand. So suppose this is a salt is given AgBr, it will be dissociated as Ag plus and Br minus. Here X is equal to 1 and Y is equal to 1. So what is this X and Y? We will understand that these are the coefficients X and Y. For this X and Y, we have to study this equilibrium. Suppose Bx and Ay, this is the name of the salt. X and Y, these are the coefficient. X is the coefficient of B, Y is the coefficient of A. This will be dissociated as X B raised to Y plus Y A raised to X minus. So this salt will be dissociated like this. KSP is given. Now you are familiar with this KSP. This is a solubility product. So KSP is given B raised to Y plus and raised to this coefficient X and A raised to X minus raised to Y. So this is the solubility product is given. Now we are coming to the molar solubility, where if S is the molar solubility of the compound, then equilibrium concentrations will be given like this. Now in molar solubility, this B raised to Y plus is equal to X into S moles per liter, where S is the molar solubility, moles per liter, and A raised to X minus is equal to, concentration is given, is equal to X S moles per liter. This is a given for your understanding purpose. What is meant by X and Y? If you understand the X and Y, then I am coming to the next slide. So solubility product is given. Solubility, in the solubility product, we have to keep these values in this equation. So instead of B raised to Y plus, we are putting this value, and instead of A raised to X minus, we are putting this value. So we are interested in this product, X raised to X, Y raised to Y, and S raised to X plus Y. Now coming to these examples, we will understand, because this is required for our numericals. So this will be not asked for the examination. So don't worry about this expressions, equation number 3.29. No one will ask to derive this equation. For the understanding purpose, this is given how the molar solubility is calculated. So again, we are coming to this example. Now we are familiar with this x and y. These are the coefficients. So KSP for this example is s into x is equal to s square. Come to this second example, PbI2. PbI2, it will be dissociated as Pb2 plus twice I minus, where x is equal to 1, also y is equal to 2. So the solubility product is given 1 raised to 1, 2 raised to 2, and s raised to 1 plus 2. According to this formula, it is given, so it will be 4 into s cube. By solving this, we can get this one. So directly I am coming to the example. First, I will explain these conditions of precipitation. When the precipitation depends upon the ionic product and solubility product. So there are three possibilities when ionic product is equal to solubility product. Solution is saturated. There is a equilibrium, solubility equilibrium is exist because IP is equal to KSP. IP is called as ionic product and KSP is the solubility product. So no any precipitation will be formed when these values are same. IP and KSP values are same. No any precipitation will be formed, because for 1 mark this is important. This is not deleted purposefully. Remember, this part is not deleted purposefully because we want to ask 1 mark question on it. Then when the KSP value is less and ionic product value is more, then and then only the precipitation will be formed. So remember this, for red color purposefully it is given when the ionic product value is more than the solubility product value, then and then only precipitation will be formed and the solution will be super saturated. When IP is equal to KSP, the solution is saturated. When IP is more, then precipitation will be takes place and solution will be super saturated. And opposite to this, when KSP value is more than the IP, solution is unsaturated. I mean, we can also dissolve the solute in it. So in the case B, only the precipitation will be takes place. So this is the condition of precipitation, because for MCQ purpose it will be given. Write the conditions for precipitation. So we have to write when the ionic product of the solution is more than the solubility product, then the solution is supersaturated and the precipitation will be occur. So for this statement, this part is included, remember. Here also it is given what is the difference between ionic product and solubility product. So ionic product is an expression contains concentration of ions under any conditions. So it is mentioned here, concentration of the ions under any condition, and in case of solubility products only we are considering the concentration at equilibrium. So this one example is given. This is very easy example. See, the solubility product is given. KSP is given 5 into 5.2 into 10 raised to minus 13, and what is asked for to calculate its solubility in moles per dm cube and grams per dm cube. Molar mass is given. So we have to use this formula. By using this formula, we can calculate the solubility. What is given? We have to the solubility product is given, KSP is given, and we have to calculate its solubility. So by using this formula, we can calculate solubility is equal to molar solubility into molar mass. So how the numerical we have to solve, we will check. The solubility equilibrium, first we have to write the solubility equilibrium of this AgBr. AgBr will be dissociated as Ag plus Br minus. Here X and Y are same because the coefficients are no any coefficient. So it will be considered as 1, 1. So The KSP, now you know how to write the KSP values. KSP is equal to the molar concentration of Ag plus into the molar concentration of Br minus in saturated solution, because we are familiar with this KSP. So as it is 1, 1, KSP is equal to S square. So S is equal to, we have to take the under root of this KSP. So S is equal to under root of KSP. KSP is given. So under root 5.2 into 10 raised to minus 13. This is given. AGBR, KSP of AGBR is given. So by solving this step, we will get, this is the solubility in moles per dm cube, 7.2 into 10 raised to minus 7. Means half of the part of the numerical is completed by using this equation, 7.2 into 10 raised to minus 7 moles per dm cube. So if you solve up to this, we will get 1.5 mark. Then remaining part, for this remaining part, this formula, we have to use this formula. The solubility in grams per dm cube is equal to molar solubility into molar mass. So by using this formula, solubility also, we already calculated the solubility. So we have to put the solubility, solubility in grams per dm cube. Molar solubility, it is calculated. Molar solubility in moles per dm cube, it is calculated. So we have to put this value from this above numerical, 7.2 into 10 raised to minus 7, and molar mass is given. See, in the example, molar mass of AGBR is given. So directly we have to take this value. Means only we have to put the values and do the calculations, multiplication, and we have to solve this square root. Directly we will get the answer. So no any, I think, difficult part is there. Only the difficult part is, only we have to solve this square root. This is only the difficult part. Otherwise, all the things are given. So this is a numerical for 3 marks, remember. Only the values will be changed. This value will not change because this is a constant value AGBR, but they can change, they can, instead of AGBR, they can give AgCl. Instead of this AgCl, they can give AgI also, or different salts. So the type of the numerical will be same, only the values will be changed. Only we have to understand how to solve this stepwise. So actually this is sent to you, this PPT is sent to you. Again, today I will send the updated PDF file of this ionic equilibria. Check whether the solved numericals are given or not. Again, the second numerical it is given, you can solve at your home. And last part of this chapter is common ion effect. This 3.10, it is not evaluated part, remember. This is a non-evaluative part, this 3.10.1. This is a deleted part. No any question will be asked on 3.10.1, common ion effect and solubility. But the question will be asked on this, remember, what is mean by common ion effect. Purposefully it is not reduced because we want to ask 1 mark question on this. Total weightage for this chapter is 6 marks. So one numerical will be there. If the numerical is asked for 2 marks, then theory will be asked on 4 marks. So out of these 4 marks, 2, there will be the combination of 2 plus 2 or 3 plus 1. 3 plus 1 means again there will be the 2 plus 1. Because according to the question paper pattern, we can prepare the 3 marks question in combination. We can prepare the 4 marks question in combination also. 2 plus 2 also, 3 plus 1 also, 1 plus 1 also we can prepare. So the combination will be there. Don't worry about the longer questions. No any one question for 4 marks. This is not possible. So there will be the mixture of questions. Suppose question number I am talking about the last question in section D. 27, question number 27, it is for 4 marks. So question number 27A, it will be for 2 marks, and B, it will be for 2 marks. Or question number 27A, 1, again this 2 marks question can be converted into 1. So there is a choice for examiner how to construct the question. So for 1 mark, they can ask the question on this common ion effect. What is mean by common ion effect? So we will discuss about this common ion effect. By the title, we can understand common ion means there should be a common ion. Now you are very familiar with this, what is mean by weak acid, what is mean by strong acid, what is mean by strong base, weak base. We are very familiar with this concept. What are the weak acids are not dissociated completely, but the strong acids and strong bases can be dissociated completely. So again, we are going to take the solution of weak acid. Acetic acid is taken here, CH3COH. This is acetic acid. See, the weak acid is acetic acid. We are going to take the acetic acid, CH3COH, and its salt is given CH3CONA. This is a sodium acetate. So weak acid, it will be dissociated partially, double-headed arrow indicates it will be dissociated as CH3CO minus and H plus. And on the other hand, CH3CONA, this is the strong electrolyte, it will be dissociated completely and it will provide the ions CH3CO minus and Na plus. As it is a strong electrolyte, it will be dissociated completely. That's why it is shown with single arrow, and this is a weak electrolyte. It is shown with a double-headed arrow. This both the acid and the salt. See, observe this dissociation carefully. We can find this is a common ion CH3CO minus and this CH3CO minus. Both the acid, weak acid, and the salt produces. This is the common ion in the solution. As it is a strong electrolyte, CH3CONA dissociates completely. It will provide the large concentration of CH3CO minus. Now, again, I am coming to the 11th standard. This is the 11th standard concept, Le-Chatelier's principle. So, this Le-Chatelier's principle in 11th standard, it is explained. What is this Le-Chatelier's principle? The factors affecting on equilibrium are given in the Le-Chatelier's principle. It is included in 11th standard. But only we have to remember out of this, there are factors affecting on temperature, factor affecting on pressure, factor affecting on use of catalyst. There are many factors in 11th standard. Only here, Le-Chatelier's principle, we are considering what is the factors affecting on when the common ion effect, common ions are there. So according to the Le-Chatelier's principle, the addition of CH3CO minus, we are adding CH3CO minus from CH3CONA, means this strong electrolyte. Addition of this CH3CO minus ions from this CH3CO minus Na to the solution of this CH3COH. Once again, I am repeating, this is quite confusing to understand. So, Le-Chatelier's principle क्या बोलता है कि addition of CH3CO minus, this CH3CO minus coming from the strong electrolyte to the solution of this CH3COH, then what is happening? This equilibrium will be disturbed. So this equilibrium of this CH3CO and this equilibrium will be shifted to this side. This equilibrium will be shifted to the left hand side. So what is this equilibrium? I will explain. There is a combination of this CH3CO minus and H plus, and we will get, this is a undissociated CH3COH we will get. So the equilibrium will be shifted to this side. Which side? Left hand side. Again, I'm explaining why this is happening, because we are adding the CH3CO minus from this CH3CONA to this solution. If these CH3CO minus ions are added, this equilibrium is disturbed. It will be shifted to this left hand side. So what is the effect of this left hand side? The reverse reaction is favored. This reverse reaction means there is a combination of CH3CO minus. This is given here. The reverse reaction is favored, in which the CH3CO minus, it is given here. The CH3CO minus combines with H plus. So H plus is already there, and we will get the undissociated or unionized CH3COH. Hence, now we have to prepare the definition of common ion effect. Hence, the dissociation of CH3COH is suppressed, means it will be stopped. Means the dissociation of this CH3COH will be stopped. When it will be stopped? Due to the presence of CH3CONA. Due to the presence of this CH3CONA containing the common ion CH3CO minus. So we will prepare the definition of the common ion effect. Means the dissociation of weak electrolyte, it is suppressed due to the presence of strong electrolyte containing the common ion. So the definition is given here. See the definition of common ion effect. The common ion effect states that the ionization of weak electrolyte, it is suppressed, means it is stopped. Ionization of weak electrolyte, it is stopped due to the presence of strong electrolyte. See in this example, the strong electrolyte is CH3CONA. So the dissociation of CH3COH, it is stopped due to the presence of CH3CONA. Actually, there is a common ion in between this weak acid and its salt. Its salt CH3CO minus is common. So due to this CH3CO minus, the dissociation of weak electrolyte is stopped due to the presence of common ion. So the definition is prepared. The dissociation, ionization or dissociation of weak electrolyte, it is suppressed due to the presence of strong electrolyte containing a common ion, to the weak electrolyte. I think you can understand this common ion effect. It is only one step we can write. Common ion effect, it is due to the common ion which is present in weak electrolyte and its salt. So the dissociation or the ionization of weak electrolyte, it is stopped due to the presence of common ion, and which is present in salt also. So due to the presence of common ion, the dissociation is stopped. Dissociation of weak electrolyte is stopped. So this can be asked for the definition purpose. This can be asked for the definition purpose. What is meant by this common ion effect? It is very easy. Common ion effect, it is an effect due to the common ion which is present in both weak acid and its salt. So this is for your knowledge. It is given for the students we are who preparing for the competitive examination, JEE, NEET, and different examination. For example, ISER, KVPY, then BITS Pilani. These questions will be asked for that exams. Keep in mind. So what is this Lee-Chatelier's principle? It is given. A common ion effect is a special case of Lee-Chatelier's principle in which when the stress means when the what we can say, stress is applied to the equilibrium, means when the equilibrium is disturbed, that is called a stress here. So what will happen if the stress is applied to an equilibrium system? To an equilibrium system, and increase in concentration of one of the products.